Hello, my name is Ruben Garcia, and I'm in General Bio 1. Today I'm going to be talking about the photosystem. Here I have like a image of it. It's not colorful, just black and white. Okay, so first I'm going to start with the photosystem 1, which is starts here. And the pigments in the antenna complex absorb photons and pass the energy to the photosystem 1 reaction center, which is somewhere near here. You can see right there. Electrons are excited in reaction center chlorophyll molecules. The reaction center pigments are oxidized, and the excited electrons are passed through to a series of carriers inside the photosystem. Then ferrexidine, which is gets in, and then it starts a cycle right here where you can see the photosystem 1, which is the electron transport chain, to the enzyme called NADP plus reductase. NADP plus reductase transfers two electrons in a proton to reduce NADP to form NADPH. The reason that photosystem 2 occurs is to produce ATP, which is a form of energy. Photon light hits the antenna complex, energy travels to reaction center, electron is accepted by phosphatine, then is transferred to plastoquine, which is the PQ, and then step down in energy along an electron transport chain. After that, it goes all the way and then goes to the Calvin cycle. And the purpose of this Calvin cycle is to reduce the carbon dioxide inside this system to produce sugars. It has three phases: fixation, reduction, and regeneration. All three phases of the Calvin cycle take place in the stroma of chloroplast. The reaction occurs in a cycle. One turn of the cycle fixes one molecule of CO2. Three turns fixes three molecules, and it takes 6 rotations to produce one glucose. After that, we go to the C3 plant, which is right here, G3P. The purpose of it is that the C3 carbon fixation is one of the three metabolic pathways for carbon fixation. In photosynthesis, along with C4 and CAM, this process converts carbon dioxide and ribulose biphosphate into a 3-phosphoglycerate. After that, it comes to the G4 plant, which is common in mesophyll cells near just a bit close to the leaf of the plant where all happens. 3-carbon compound and CO2 with PEP carboxylase produce 4-carbon organic acid. And step 1 is PEP carboxylase fixes CO2 to a 3-carbon molecule in a mesophyll cell. The 4-carbon molecules that result are transported to bundle sheet cells by channels called plasmodesmata. The 4-carbon molecules are broken down to release CO2 molecules. Bundle sheet cells, which are less permeable to gases, so CO2 concentrations rise and promote carbon fiction by Rubisco to form 3PGA. This step initiates the Calvin. It all adds up to that. That's a brief summary of the photosystem. Thank you so much.